Hello everyone, Professor Ray here. We're starting up round one, linear motion with constant velocity. We're not going to be doing like full-fledged physics problem solving yet. That's coming. But in round one, what I really want to focus on is drawing a picture. Drawing a picture is always the first step when you're trying to solve a problem. And when you are, drawing pictures for physics, what we're really trying to do is take situations like this. Like this is the motion. This is what we're going to be looking at in terms of mechanics. We have a object that's moving. It's moving in the say one direction or the other direction. We get to describe how it's moving. In real life, we get to see the darned thing as it is moving. But when we start to solve physics problems, we have to imagine what's going on in our mind based on a question that is being read, right? Either we're reading it or is being read to us. And then from that picture, from that question that we read, we have to draw a picture. And not only when we're talking about like pictures of how this thing is moving, we have to say, here's where it starts, here's where it ends. So let's just get to an example here, right? This picture is always going to include three things. It's going to include what we call the coordinate axis, the positions, usually 2 points, right? We're not software or data collection machines that can draw this over and over and over and over again. So we're usually just pick two positions when we're solving problems, and then we draw velocities associated with the positions we're interested in. So we have a coordinate axis that we get to define where that origin is located. Where's the starting point? Where is 0, 0, right? In this case, we'll say position x equals 0 because we're dealing with things that are moving left or right. Horizontal motion. This could also be y if we're dealing with vertical motion. And you typically have to define which direction is positive. Typically, we say to the right where direction is positive. For these videos, hopefully it all works out. Let's see. Hopefully that way's the positive direction. We'll find out. I'll watch it after this here. Okay, positions, right? Now the motion is continuous, as noted, right? There is the motion. It is continually moving. But we usually pick 2 points, right? Usually it's the beginning, and then some other point as it's moving that we are trying to determine, well, what's its position at after so many seconds? What's its velocity after so many seconds, right? So the motion is continuous, but we pick 2 points of interest, right? Those points are indicated with a dot, and we usually label those with like x1 and x2, okay? Then velocities, right? Those are the velocities at these points, right? So as it's moving, it has a velocity right there, it has a velocity right there. As it's moving, we could indicate the velocity with arrows, right? Those arrows will point in the direction that it's moving. So these arrows will be pointing in that direction and would be, so big. If you have something that's moving faster, you have a big arrow compared to something that is moving slower, where you would have a small arrow. For example, draw arrow, big velocity to the right, small velocity to the right, and that corresponds to the actual physical thing moving in space. All right, those typically label those with like a V1 or an X1. So when I label those, I'll label it up at the top like V1, V2, right? And your positions would be like, there's the position X1 that's moving with a velocity V1. This is my position x2 that's moving with a slower velocity v2, right? Of course, I probably should put that on the other side of the page because it's moving left to right, but it's however it goes. All right, so here's what we're going to do. Swimmer A starts at one end of the pool and swims to the finish at constant velocity. You can see that here down below. We have a start, we have a finish, and then there's your swimmer A, a nice little circle, right? Now that circle, is that the position we're wondering about? No, it's just saying, hey, I have someone who's just going, right? It's just that it just represents the motion or a certain location of the swimmer, right? The swimmer moves from A to B. It moves from start to finish. That just represents somewhere in between, such as here's your start, here's your finish. Right there would be where the swimmer is, right? But we want to know in regards to this, if I have the beginning and if I have the end, right? The swimmer's already moving, right? The physical pictures provided, what I want you to do is I want you to, below it or above it, draw a coordinate axis, positions, and velocities. And after you've tried that, respond with yes, ready to move forward, and then I'll draw. Okay, here we go. So I would do this, and hopefully you've done the same. You've given it a try, right? I'll do right below. I want a coordinate axis. I'll draw my coordinate axis in black. All right. So here we go. Coordinate axis is to the right. This is going to be a positive x direction. The origin, well, let's just say I put it at the start, right? There's my start. This is where my x is equal to 0, right? There's your coordinate axis, all done. Now from here, I'll do my positions in blue. Why not? Okay, so again, I could choose any two positions that I'm trying to compare, right? But the swimmer starts at one end of the pool and swims to the finish. And so with this case, I'm going to choose the start as one location. I'll call it this x1. And down here at the finish, I'll call this x2. Right there. I'll write it down there on the coordinate axis. I could have written x1 on the coordinate axis, but that's right at the origin. So x1 in this case is equal to 0, right? Why did I do that? Because the question's kind of asking, hey, you start at the start, you end at the finish. I could say, how fast are you going, or what time are you in the middle? And in that case, you would have your x2 moved to the center of the pool as opposed to x2. So this is, like I said, guys, this is what's going on right here. That's the actual thing going on. Swimmer's going and gets to the finish all the way over there. We're just picking 2 points in this motion to draw our picture. And we're assuming some constant linear motion in between. Now, if the motion in between is constant, well, I'm going to draw, let's see, it's moving to the finish. So I'm going to draw an arrow to the right towards the finish. I'll draw it yay big right there. It should be directly to the right, but it just kind of squeaked its way up a little bit. So there's V1. Now, if I were to draw the velocity at 2, what would be different? Anything? Would the direction be different? No, still moving to the right, right? I'm not saying you've hit the finish line. You're going through the finish here, right? So you started, you're moving at constant velocity, V1 to the right. X2, when you're at that, if you're moving at a constant velocity, the direction will be the same, and the length of the line, which tells you how fast you're going, will be the same. All right, now this, you might have been like, oh my gosh, Dr. Ray, why did you have to make that so, it's not complicated, right? It's not complicated, guys. 2 dots, 2 lines, coordinate axis. But we have to understand that this picture is what's representing what's going on behind us. And we're assuming what's going on in between these 2 dots, right? And it's super, super important in that problem-solving process to be able to take the question, draw a picture from that, and then from the picture, extract information. All right, we're going to get a lot of practice with this. So if you struggle with that one, don't worry. We'll get some more practice, quality practice. So when you get to the homework, get to the quizzes, and eventually the exams, you're going to be ready to go. All right, everybody, off to round 2.